Okay, so I'm talking about points of discontinuity on 9 and 10. They want to know if it's removable or non-removable, yes? So if we want to know if it's removable or non-removable, what's removable mean? Removable means there is a hole. Whereas what's non-removable mean? Non-removable means there is a vertical asymptote, right? So that's a memorization thing right there. Okay, you've just got to flat out know those. As we look at this, knowing the fact we're talking holes and vertical asymptotes, whether it's holes, whether it's vertical asymptotes, the idea is you always set the denominator equal to 0, yes? Now the catch is, if it's vertical asymptote, you set the denominator equal to 0, no big deal. If it's a hole, though, whatever that factor is that makes the hole, that factor is going to be in the numerator also. It's like if I look at 10 here, is there any factoring that can be done? X is on top, x minus 3 is on bottom, so when we set our denominator equal to 0, x minus 3 equals 0, and so we get x equals 3, right? Or in other words, it's x cannot equal 3. Without looking at the graph, I know whether this is vertical asymptote or a hole, because is there another x minus 3 factor on top that can cancel? And there's not. So I know that this is a vertical asymptote. I also know that a vertical asymptote is non-removable. Okay, so the question was, how is it stated? Determine where the function has a point of discontinuity and tell whether it's removable or non-removable. So where is at, where did we talk about? X equals 3. So there's a non-removable point of discontinuity at x equals 3. Now, as we look at 9, and by the way, I know the answer key, it says, inspect the graph, right? I'm showing you algebra. I'm also saying, yes, inspect the graph. There would definitely be an obvious break at 3. Okay? But to find out the where, set the denominator equals 0. Over here on 9, is there any factoring that can be done? And what do you notice on top? There's a GCF of x. I'm actually going to write it out right here. So GCF of x means if I factor an x out on top, x squared divided by x leaves me with x minus 6x divided by x is 6. Now, what do you notice when you go to set that denominator equal to 0? There's a common factor there, isn't it? So when I set that denominator equal to 0, which is x equals 0, are we thinking it's going to be a vertical asymptote or a hole? Well, because these x's can cancel, because there's a factor that can cancel, it's going to be a hole. Which means when you look at the graph, are you going to be able to see it? Not really. Okay, so holes are removable. And where is this removable discontinuity at? At x equals 0. So wherever your denominator equals 0. And I don't remember how it's set up on the test, if you just have to tell me removable or non-removable, or if you have to be able to state at x equals what. But, okay. So I felt like that was a good thing to review. I know it was a problem on the quiz, so good thing to discuss there. Other topics you guys are interested in?